we're going to come back to the concept of the limit in a multivariable function. And when we began at the very beginning, I made a statement that sometimes our Calc 1 or first year calculus algebraic tricks can be used. But finding the right situation to use them may or may not be possible. So then we explored a couple of ways of dealing with two variable limits of a function of x and y. We're going to come back to a different kind of limit. As you can tell by the title, I at least claim that it's very special. You could say that it's going to become the single most important tool in the entire rest of the course, not in its form you're about to witness, but in the result that follows from it, which will happen soon enough in this series. So we have this function of xy equals x cubed plus 2x squared y plus 5y squared. And we're going to evaluate the following limit as delta y approaches 0. F of x comma y plus delta y minus f of x y divided by delta y. I truly hope that this particular limit looks familiar to you. I hope it does. But if it only is vaguely familiar, you're not going to be hurting through this example. But you should note that if delta y becomes a 0, that the denominator will be 0, and you will have, well, that'll be f of xy minus f of xy, and you will truly have a 0 over 0 indeterminate form that comes up. If I do the substitution, what I'm told to do here, limit delta y approaches 0, is wherever x is, stays x. X cubed plus 2x squared. But wherever y is, that will be replaced by y plus delta y. And then this would be plus 5y squared, but y is replaced with y plus delta y. And then it's tough to fit this on a traditional piece of paper here, minus the original function, x cubed plus 2x squared y plus 5 squared y squared. The entire expression divided by delta y. So we're just going to walk through the algebra that follows from this. Let's see if I can create a little bit more width on my paper here. Limit delta y approaches 0. Let's see here, I'll have x cubed plus 2x squared times y plus 2x squared multiplied by delta y plus 5 times, now I'm going to ask, if this next step is starting to look fast, pause the video, write out this multiplication here, then multiply by 5, but I have to keep going. 5y squared plus 10y delta y plus 5 delta y squared minus x cubed minus 2x squared y minus 5y squared, all of this over delta y. And then I pause and look at the lovely little algebra mess I've created and see, oh, x cubed minus x cubed is 0. 2x squared y minus 2x squared y is 0. 5y squared minus 5y squared is 0. And every term remaining has a factor of delta y in it. Limit delta y approaches 0. If I reduce that, so this is basically two algebra steps at once, plus 10y plus 5 delta y. I believe that's everything that's left after I reduce by a factor of delta y. What was I doing again? Oh yeah, I reduced the fraction. I no longer am dividing by 0. If delta y is 0 here, I will get 2x squared plus 10y. Now, this came from this function. I don't want to spill all of the information immediately, but I'm going to point out two things. One is we were definitely acting on the variable y in this limit, not on the variable x. So when you're looking at the y terms here and you're looking at this answer, it might help you to understand what's happening. Second, I wonder what would happen. What if we were looking at the limit with the delta x approaches 0 and all of the x terms were manipulated, but not the y terms? So I'm going to suggest that you try this very problem that way. It's a little bit more, we'll call it fun, because of the cube expression. And if you have some experience, then you're probably watching this only to watch some of the algebra substitution steps take place. If you have no experience, then you're just doing something that looks a lot like Calculus 1 applied in a more advanced calculus class. I will tell you the name of this thing. What we're doing here is called a partial derivative, but I don't even want to write it down yet because that's coming soon enough. Stick around, I'll show you this calculation.